Hello, we are here today to talk about making tools for making games. I am Ahmed Gamal, and I'm a games development lecturer here in SAE Institute, and I have been teaching games for more than 5 years now, and I also worked on games for more than 7 years. I love Assassin's Creed, and I personally believe that you can tell a lot about the person in front of you just by knowing the games that he loves. So this is how I like to introduce myself. I also worked on making tools for Unity 3D for a long time, and I published one of them, which is called GVX. It's a tool to create visual effects, real-time visual effects for games. So this is to help developers, and it was also like an experiment of mine. So here it is, if you guys just to see an example of my work, and just to see an example of what we can do or what you can do with tool development. So who is this session for? This session is for game developers who didn't make tools before. So this means that you need to have prior knowledge in programming. And you also are willing to optimize the workflow a little bit and make things faster for you. We are also going to cover the basics, just the basics. So this means if you already know a lot about tool development, then that's not going to be very important for you. So here's what to expect from this session. We're going to talk first about why. Why bother about making a tool for making your game anyway? And then we're going to cover some of the common examples where tools are very helpful and useful. And then we're going to talk about Unity 3D and extending it by writing some editor scripts. So this should enable you to create tools for Unity 3D. So first, why bother? So tools save time, just like a game engine does. And if you think about it, game engine is actually a big tool that we use. It just makes all the common practices or all the common things or all the common features that we need to do while we are making games, and they package it together and make it easy for you to reuse. This is what a tool does in the first place. So tools save time. And then it minimizes the donkey work. We all know how much time and effort game development takes. So minimizing any kind of work that you need, the repetitive tasks that's related to content creation or generation or something like this. So all of this stuff you don't really need to do by hand or manually. So it minimizes this kind of work. There is also no need to reinvent the wheel. So whenever you create a tool, then you should be able to reuse it again in any other project. So this is going to also save a little bit of time. And then many game projects actually have unique features, unique things that you can only do by creating a tool. It's going to be different from every feature that you find in a game engine. So this is why if you're feeling that the game engine would have a great feature, an extra feature that help you make your game, then you can make it yourself. You can make the tool yourself. And then finally, of course, you can make a little bit of money by selling them. So that's great. Here are some examples. Level editors. Level editors are great tools. And in many games, in many cases, after creating the game, you can publish a level editor so that the users can create some levels, some extra levels for themselves. There is also the asset importers and the asset exporters. So imagine if you are doing a 3D model, but then you want to generate some extra information when you import it into the game engine. Some extra information like the colliders, for example. So this is, you can do that by asset importers and asset exporters from the software, the 3D software itself. You have analytics and visualization as well. So you can make some tools to collect data or testing data about the game, or you can collect some tools to visualize, like, for example, if you have the path finding and then you create some tool to visualize the path that's chosen or the different options. So all of these things, tools can help you with. Of course, content generation, like generating a crowd, for example, generating traffic or controlling traffic or creating the different roads where the traffic should go. Generating city buildings, all of these things are very fast using tool development. Here is also an example from Unity, or actually, this is a company that created Pro Builder, and it's like a small 3D Max that's inside Unity. And Unity have both them now because the tool is amazing. It makes everything really easy, and it's a really good example because you can find it doing a lot of stuff using all the different topics that we're gonna cover today, and even more, much more topics that we are not gonna cover, and you can learn on your own. So this is a good example where you can start, and you can see also the code for it. So I hope you are convinced now about tool development. So let's start coding and talking about some examples. We will start by covering some few terms that are common in tool development so that you learn about what they do and how to use them. So the first thing is attributes, which is quite common in programming. It's a C# thing. It's not a Unity thing. So you can define your own. This is in C#. And rather than just defining your own, you can use the ones that come with Unity, which make things a little bit easier. We're going to cover some examples soon. And then handles is another key term that you need to understand and know. And handles are these extra shapes that you find in the scene view. So if you are working with Unity and you see like this axis to show you the 3D direction or control the position or control the size of an image on the screen, all of this is basically handles. All of these things are basically handles. Now, Unity allow you to define your own handles, and you can customize the behavior of them. So this is also another tool that you might need, or another key term that you need. Another key term here is editor window. Now, the editor window is basically any kind of window that you use in Unity, any kind of separate window that you can basically dock, or you can make it a floating window, something like the animation window, for example, which has a lot of tools, and it's used to create or control the animation and control the animation curves. So all of this are editor windows. Then there is a custom inspector, and the custom inspector basically is how your component or your code is going to show up in the inspector. So we create components as game developers, but these components can look or appear in a different way. So this is related more of controlling one game object that's selected. And it also depends on the concept of serialization. You have custom property drawer, and this basically means when you have a variable of a specific type that need to show up in the inspector, then how it's going to show. An example for this, if you have like a 2D array, and then you want to show this 2D array in something like a table. So you can write a different property or a custom property drawer so that you can draw it in the ways that you want. And then there is gizmos. And the gizmos are this extra wire shapes that enables you to control some stuff, and it doesn't represent really anything in the game. It's similar to handles, but gizmos are most of the time little bit less interactive. They don't control anything. They just show you the range of something. They show you where a specific, like the light, for example, where the light is. So all of these are called gizmos. Now the serialization, as Unity defines it, the serialization is an automatic process of transforming data structures or object states into a format that Unity can store and reconstruct later. So if you ever wondered why Unity doesn't save the changes that you have or that you do while the game is playing in the editor, this is because it's a completely different object. The object that you are editing while the game is playing, it's a completely different object in memory. The way Unity works is that it serializes every change that you do while you are working on an object in the editor and the game is not playing. So every change that you do, it's serialized, it's saved. Whenever you play the game or whenever you reload the project, then all of this data is going to be deserialized and loaded. So this is called hot reloading. Here is a simple visualization example. So let's go to Unity, and this is an example for custom gizmos. So I have this object here. It doesn't have any colliders. It doesn't have any shape or any mesh. I just have my script, the gizmo demo script. And when I open this script, you can find that there is two functions here that can do that. OnDraw gizmos and OnDraw gizmo selected. The first function is being called whenever this object need to be drawn or a gizmo need to be drawn for this object. So if I'm not selecting this object, you can see that there is a gray box here, a faded gray box. This is done by calling gizmos.drawCube, and then I gave it the size and the position. This is also how I can control the color. And I just added this line of code so that if size is not initialized, then I just initialize it by the values that I want. And then the other function, which is OnDraw gizmo selected, this is the function that basically is used to draw the gizmos when it's selected. So you can add extra stuff like I did here. I just added this outline, yellow outline for the cube. And I can do this by also using a function in the gizmos class that's called drawWireCube. And then let's see a simple example for the inspector. Again, this is very simple. So we're just going to talk about the attributes that can control how things look like in the inspector. So you can see here that the inspector is kind of formatted. So I will show you what I have done here. You can use an attribute that's called headers. And in this attribute, you just give a label for a section of variables or something like this, as you can see here. And then you can use a tooltip attribute to help you or remind yourself of how this variable is being used. You can use range to create this slider. And I use another header here. And then there is a space attribute. This creates a space between this variable and the variables on top of it. And then you have the text area attribute that can come before string variables. And this creates a text area where you can have multiple lines, have a scroll bar, and add as many text as you want. Here are some examples for attributes where you can use these attributes on classes or functions to create or extend the functionality in Unity. So let's see the menu item first. And I basically have the menu functions here class. It's a class. I just basically can make a class like for utility functions. And the function need to be static and public and void and takes no parameters. This is how you can create a function that you add to the menu. And you use this attribute, and then this is the path for the menu option. I did nothing here other than just making a debugged log, so you can do something else based on what your needs. So here you can see that it shows up as my menu block selection, and then once I choose that, then there is nothing selected, so that gives me an error. I will basically clear these errors. My menu log selected, and then it basically logs the name of the selected object using this command. And then there is the run in editor example. So you can see here, I am in the editor, and when I rotate this object, the other object is going to do the reverse rotation. Now, how I did that is that I wrote the script, and then the update function, I basically calculate the reverse rotation for myself, and then I apply it to the other object. Now, the weird thing here is that the update function runs in the editor. And this is happening because of this attribute. It's happening because of the execute always attribute. The update function, however, is not being called every frame like it runs normally in a game. The update function is being called every change. So whenever you change something, so use this only for testing positions or rotations or relations between different object transforms and things like this. Now, of course, be aware that any kind of modification that you do while execute always is there. It might be permanent. So use it only for very moderately. And then let's see a custom inspector example. So this is just a regular game object. I have here a list of prefabs, and then I have a specific radius. I use gizmos to draw this radius so that I can visualize the range. And then I have this button here. So this is what I can basically do with custom inspectors. I can add buttons, I can add different GUI elements. I can control the GUI the way that I want. So I added a button here, and when I press this button, then I'm going to generate one random object from the list. They can keep pressing. It generates within the range a random object from the list. So here is the code that I used for this. This is the game object. This is the component that I can have as usual. So it's just a regular mono behavior. It has a list for the prefabs. It has a radius, and it has the onDraw gizmos function, and it draws the circle using the range, this range. And then you have the child generated inspector. So this is what you need to do: create a custom inspector. You need to use this attribute, and within this attribute, you're gonna need to tell Unity what is exactly this inspector or this custom inspector is gonna be used for, which class specifically. So this is the class that that I wrote here, which is a child generator, the custom component that I made, and then you need to inherit from the editor class, and you can only find it when you write using Unity editor. One more thing, this class needs to exist in a special folder, just like the resources folder if you have used it before. It needs to exist in a folder that's called editor. It doesn't matter where this folder is, as long as it's named editor and then the code is inside or in any subfolder, it's gonna work. The reason why this is important, because it becomes a different assembly in the end. And this means that any code that's not needed or only editor based, then it's not going to be exported with your game. The most important function in a custom inspector is on inspector GUI, because this is the function where you can draw all of the what's going to show in the custom inspector. Also, another common function is draw default inspector. So whenever I call this function inside an on inspector GUI, it's going to draw all the default variables and all of the default things. Just like you can see here, the prefabs and the radius is being drawn using the default function. And then I added my button using the GUI functions, GUI layout button. And the difference between GUI and GUI layout is just it automates the layout for you. So it calculates the rectangle for you. So GUI.layout button, and then you just give it a label. And this is basically whatever you want to do inside for this button, or when this button is clicked, you can write it here. Now you can also have editor windows, and editor windows can control the scene, just like the animation window, as we said before, this example. So you always need to find a way to open the window. But now let's go to GVX, the tool that I created, to show you a bigger example, because this is basically how you can see a tool being used. I created this custom window here where you can preview an effect, a specific effect. So I created a little bit of a timeline. All of these are just regular buttons. I used icon instead of just text. And then you can draw the rectangle that you want. So you can select objects here. And then you can control, you can basically listen to the mouse events. So this means whenever the mouse is moving here or clicking or dragging, all of these events you can listen to, and then you can react to it. So this is like a bigger example for that. Now let me open the code for this and show you the code. So here is an example for an editor window. Again, you're gonna need to use the Unity editor in one of these using commands. You're gonna need to inherit from editor window, not just editor, so that you can have different functions that you can override. And there are many functions that you can override. You can always check the documentation for that. But of course, the most important function here is going to be on GUI. And the most important function here is on GUI. So you can see here, I try to basically use the same functions that I showed you, but a little bit more advanced, in more advanced way. So different options, the GUI layout, the same class, but it has so many different functions that you can use to create different things like an area or draw a texture. So this is basically what I used here, but it's exactly the same concept. Here is an example of how I used the custom inspector. So I added a button here to open the editor window if in case it's not open. I also added a button here to show a list of the different effects or the different presets that you can add for this composite effect or for this game object. And then for everything that you add, it basically there is a list or there is a custom visualization for the different options based on the component or the sub effect that you basically add. So this is an example of how you can use the different things or the different tips that we cover today. These are the different three buttons that basically to remove, or rename, or edit a specific effect. And when I press edit here, now I use custom handles to basically control like this, to basically control the shape and projection of this decal here. Okay, so that's it for today. I hope that I have covered a few tips that will help you with starting your tool development journey. And one last question before we end it. So should you actually develop tools? Now this is really a dilemma. It's not that easy to think about that or to spend the time or invest the time in making a tool. The project needs to be big enough so that a tool is going to help you and be efficient and very effective. Otherwise, it's going to be a waste of time creating a tool for a very small thing. So keep this in mind, try to evaluate yourself, but it's definitely a good thing to know the skill and to know how to do it. And then when you need it, you can do it. Here is my LinkedIn profile if you want to connect or you have any questions. And that's it. Thank you so much for listening.